Okay, now is recording. Okay, so if you go to your Logix Pro simulator, you can get the MCR in this tab, program control. Okay, so if you see in the tab, you have jump, label, JSR, jump to subroutine, RET, return, SBR, subroutine, TND, I've never used, I'm not sure. So MCR is master control reset. Okay, so here is the master control reset. So master control reset is the output. Okay, so let's add an input to our rung here. So here, right. Before that, let's choose IO simulator so that we can simulate our program. So let's say we put this as our input. Okay, MCR, and then let's add let's add another rung. Okay, here maybe just control an output. Okay, so the next, what happened? Okay, the next input to turn on the output here, O to 1. All right, and then let's put some, maybe, maybe a timer, for example. Forgot again. Okay, let's add a timer. Where's timer? Here, timer tab. All right, let's say we put this timer on. Okay, still remember timer? So timer always start with T4. Start with, I think, 0. You can start with 0. We choose 1. So preset, maybe we put 5, for example, or 50 as 5 seconds, right? Okay. What else? Okay, maybe we put some RTO. Okay, retentive on delay timer. So we put an address of T42 maybe. Okay, also 5 seconds or 4 seconds. All right, so let's put an input here. Oh. Input. Okay. What else? So maybe we put a counter. Put a counter up. Okay, and then here. Okay, counter up. 1, 2. This one 3. Okay, 4. All right. Where this one come out? Okay. 0, 1, 2. Okay, so and then we add another MCR, right? So program control MCR here as the second fence. Okay, so if you see here, we have the MCR, and then we have the second MCR here, and then we have program in between. All right, where we have the first rung, we want to turn on the output. The second one, we want to turn on the on delay timer. The third one, we want to turn on the retentive on delay timer. And the fourth one, we want to turn on a counter. All right, so counter, if you still remember, always start with C5. Okay, 2. Okay, preset up to maybe count to 5. Okay, all right, so can you I think I haven't upload the slide in iTaklin, right? I'll upload later, inshallah. Okay. This one I just want to show you how MCR functions. Okay. So as I told you just now, so if the input is activated, So MCR is activated, then you will have control of the programs in between of the MCR fans, right? Otherwise, if this one is turned off, this one will not cannot be executed. Okay, all right. Let's try to simulate this. Download and run. Okay. Wait, this one is already. Oh, okay. All right. So yeah, you can see that, you know, if this one is turned on, the output is not turned on. You know why? Because the MCR is not activated. Okay. And then you go to the T on. Okay. Same. Cannot turn on. Okay. Let's use this for easy showing. Okay. All right. So let's turn on the MCR. Okay. Okay. Now when you turn on the MCR, now you can see that the first rung can be executed now, right? So the output is turned on, right? If you turn off again, this one cannot be executed. Okay. So if MCR is active, whatever in between of the MCR fans can be executed. Okay. So let's try for the timer. All right. Timer. Okay. Now it's counting, right? Counting up to 5 seconds and then stop. All right. So what if we release this? It will be reset. Okay. Okay, it will be reset. So if you start again, we will counting. Okay. How about the retentive on delay timer? Retentive on delay timer. Let's try. All right. Now it's counting. Okay. We stop. The accumulator will stop at that point, and then we can start again at this accumulator 21. All right. Otherwise, for T on, if we stop, it will directly reset. All right. So let's show that. Okay, we reset. Okay, reset. Okay, as for the retentive on delay timer, because it is retentive, it will retain the accumulator. So 21. Now we'll start counting from 22 up to 40. Okay, right. That's for on delay and retentive. How about the counter? Counter, same. All right. Counter now can be executed. Right. So counter the accumulator will count when you have the transition from false to true in the input, right? Okay, false to true. Now the accumulator start counting. Okay. Okay, so that's the MCR. So if you see the definition in the slide, let's go to the slide again. Okay. Yep. Okay. Two MCR instructions form a fence or zone in a program. Okay. But you see here, when the MCR instruction is false or de-energized, all non-retentive output instructions within the fence are false, even if their rung inputs are true. Okay. So this is the okay, editing. Right. So still cannot. Let me use the.
Sorry, sir. Interrupt you.
Yeah.
I think there are students waiting for the class.
Oh, okay. Sorry. Okay, admit. Welcome to the class. Okay, don't worry. We already record this class, so you can go back to the recorded session, inshallah. So, okay. So if you go to the slide, you can see this is the keyword. Okay, non-retentive. Okay, non-retentive meaning that whatever whichever retentive output will stay at their last state. Okay. So from all of this, which one is retentive? Which one is not retentive? Can you tell me? O21 is it retentive or not retentive? O21.
No, sir.
Not retentive, huh?
Not retentive.
All right, not retentive. How about Tion? Is it retentive or not retentive?
Not retentive.
Not retentive. Okay, we'll see. All right. RTO, of course, retentive because its name is retentive, right? Okay. How about counter? Counter is retentive, huh?
Yes.
You sure? Why?
Yes, sir.
Why is retentive?
Student reset and the accounting.
Right, because it can retain, it can hold the value of the last state. Okay, so let's try to let's try to deactivate the MCR. Okay, so we turn this one to false. Okay, right, so you can see that the non-retentive output, for example, this O21 will be turned off. Okay, how about the Tion? Will be reset. How about retentive? Retentive still in its last state, right? So, right, still in last state. How about the counter? Still in this last state. All right. So every retentive output will hold its last state. All right. The same thing happen if you choose. Okay, we choose this to we go to offline. Okay, so if you change this to retentive, right? So for example, you choose, I think we have this latch. This one. If you choose this, this one, okay. Let's put as this one output, right? If you choose this, so this one will retain its last state, right? Previous state. Okay, let's try this. So, oh, sorry. Download first. Run. Okay. So active, this one will be turned on. Tion. Okay. RTO. Okay. Sorry. RTO cannot be reset. So RTO, how to reset RTO? Still remember? RTO, if you want to reset, you need to add a reset button. All right. As well as counter. Okay. So if you deactivate the input, it will not reset. Okay. The counter will continue counting. Okay. Even is after the preset. Okay, so you can see, okay, let's deactivate the MCR rung. Okay, now you can see that the latch output is, still on, right? Because it retains the previous state. Okay, okay, but you can see the non-retentive output will be turned off, and non-retentive Tion will be reset to 0. Okay. Okay. Just want to cap on how to reset the RTO. So you can add the reset function. RTO timer. Okay. Reset. Okay. So maybe you add an input here. Input. Okay. Okay, reset. You need to give the same address as your timer. So you can either, key in yourself or you can drag this. Okay. So if this one turns on, it will reset the accumulator of RTO. The same with counter. So you just, drag this one, okay, for the counter. Okay, everyone okay with this? Everyone understands? Understand what I've been talking about MCR? Okay. All right. Okay, nice. So if you have a question, you can interrupt at any time. Just turn on your mic, or because I don't check this frequently, so maybe you can just turn on your mic to ask. Okay, that's for the MCR. Okay, so if you see again your the tabs in your Logics Pro again in the program control. Okay, so you have MCR, you have jump label, all right, which is you can say essentially very similar to MCR. All right, if you go to the slide, this one, okay, this one is MCR, so you can go through yourself. Okay, go to yourself MCR. Okay, okay, now you have the jump and label. So if MCR have the fans of the first MCR and the second MCR, so jump you have the fans of jump and label, JMP and LBL. Okay, so jump at the as the first fans, and label as the second fans. Okay, so you have the somewhere in between. All right, so let's try in the Logics Pro. So can we just delete this? Okay, add the jump and label. Okay, jump and label. Okay, before that, I forgot to mention. So for MCR, I think MCR is the only function in one of the functions in PLC that doesn't have the address. Okay, the output that doesn't have the address. Okay, MCR. So you don't need to put any address for the MCR. Okay, as for the jump, it is Q2. Okay, Q2. So this one is Q2 0. Jump, and then its pair is label. All right, Q2 0. Okay, so this one will jump to this. Okay, so comparing this to MCR, just put this MCR just to show. Okay, MCR, if the input rung activates or turn on, whatever in between can be executed, right? But for the jump and label, when this one is activated, this one will be ignored, right? Whatever in between will not be executed and will be ignored. So whatever comes after the label will be executed as usual. Okay, so that's the difference of MCR and jump. Okay, MCR. Okay, let's try this. So you release this. Okay, download. Before that, let's put something after the label. Okay, just to see that everything after label will be executed. So put input here and output. Okay, so this one, then okay, download the program and run. Okay, now you can let's turn on the first rung. Okay, now you can see that the output is turned on. Okay, as well as the turn on, RTO and counter. Okay, okay, now it can be executed, right? So what if we turn on the input rung of the jump? Okay, let's turn on. All right, and try to execute the second rung. Right, so you can see that this one is not turned on. Right, O21 cannot be turned on because right now what happened is that the PLC will go to the jump instruction and then will ignore everything here, right? It will not scan whatever in between, and then it will scan the next one. Okay. Okay. Now let's try the second rung. Second rung is the T on, right? Cannot, huh? It's not counting. The accumulator is not counting. All right. RTO already the preset you cannot see. So over counter, right? It's not counting up. Okay, because it actually ignores whatever in between jump and label. All right, but how about this one? Okay, I10 I110 here, right? So it will go to the label and execute whatever next. Okay, right, let's turn off this. Okay, now it will scan like usual. Okay, all right, so this is very useful, you know, if you have a very big program and then you want to ignore some part of your program. Okay, because you have different functions or you want to add another application. So instead of, you know, directly delete this, because maybe you want to reuse this you know, sometimes, right? So instead of deleting all of this, you just, you know, ignore this by putting jump. Okay, you know, in C or in Python you can put some comments, right? You can comment out the program to you know, to ignore some part uh, of the lines, right, of the codes. Okay. Okay, so everyone is okay with my explanation of MCR and jump level? Okay.
Yes, sir.
Okay.
Understand.
All right. Understand. So you have any question on this too? I think this one is quite simple, huh? But you need to make sure you know the difference of MCR, right? Which one will activate, which one will ignore. Okay.
Sir, can we put some conditions before jump? I mean, if something happened that we activate the jump.
Yep, you can always do like that. So what condition you want to put, for example?
I mean, like if the counter was less than 5, it's like that.
Yep. So if that is the case, you might want to use the compare. All right, compare. So
we need to use
maybe you put the equals here. So this one maybe counter, right? So counter what? Preset. Let's check the data files. Counter. So counter, you have the preset accumulator, right? So let's say you want to put a conditions, for example, if the counter is 5 equals to 5, this jump will execute, right? So what you can do is something like, okay, C5. So I just put some counter, right? C5 1 is preset or accumulator kan? Accumulator. So if the counter accumulator is equal to 5, this one will be executed, right? Is that what you mean?
Yeah, yes, sir. Yes, sir.
Okay, right. So you can always you can put anything here. So put conditions, right? Put more input here, So this one is just part of the whole program that you you program the ladder diagram, right? Okay. Any other questions? Any other questions to ask? All right. So, in the exam, I might ask, I put some programs here, and then I ask if the jump here is activated, what happened to T on, for example? What happened to RTO? What happened to the accumulator of the RTO? Something like that. Okay. And you need to provide the why it happens like that. Okay. Okay. So, any other questions before we move? All right. So before, yeah. Any questions?
Sir, just now you run for jump, and then
Okay.
input 1 is on. Why is it? Why is it so?
Because it's already turned on.
But not for input 1, 2, 1, 3.
Yeah, because I didn't
Oh,
switch this on.
but
So,
it will not execute it, right?
So if jump
When jump,
is on, it will
yes.
not be executed. Yes, it
But
will be ignored. Yep.
oh, okay.
Yeah. So let's try this. Right? Open. So run. Okay. So now everything is turned on. So if we turn this on, okay, let's download first. Okay. All right. Which one? Okay, run. So this one already turned on. So still turn on. Why?
Maybe because of
because we have the equal here. Because we have the equal here.
You try to remove it
Right.
first.
We remove this. We need to download. So any changes you need to download again. So
Yes.
run. Okay. So now the jump is activated. So the output is not turned on, right? Even though
Okay.
the input is turned on.
The input is on, but the output is not.
Not turned on. Yep. So
Okay.
you can see the same for the T on. All right. And also the counter up. Let's try. Okay. It's not counting. Okay.
Okay.
All right. If you turn the jump off, you can execute like normal. Okay.
Okay, thank you, sir.
All right. So any other questions? Because comparison. Yep. Thank you. But enable pin T on still on. Enable pin on still on. Yeah. Enable pin on still on because I think because the input you have the input in the rung. Okay. Because enables always turn on when you have the input in the rung. Okay. Okay. If you don't have, okay, before I forgot. Okay. So this one is jump from JMP to label, right? What if we have label first and jump at the second? What will happen? Anyone?
Nothing happened.
Nothing happened, huh? Any other answer? So right now we have jump here and label. So if this one is activated, so this will jump directly to label. What if label is at the first rung and jump here?
It will loop.
We will loop, right? We will loop. So you try by yourself at home, okay? After this, you change the label and jump, see what happened, okay? So it will loop. Is it true? You see by yourself, okay? All right. So today we have covered on MCR and jump label, right? Okay. So now we have another one. So if you see here, program control, right? So jump label. Oh, okay. Jump label. So and then you have the JSR and subroutine. Okay. What is JSR and subroutine? So if you still remember what you learned in C or in MATLAB or Python, you have the functions. All right, so this one acts similar to functions, or I think in C++ you also call it routine, right? Subroutine. So this one functions similar to that one, because sometimes we want to repeat the same task multiple times, right? So instead of putting it in our main rung, all right, and we mess our rung. So let's say, for example, you want to flash your light, all right? So instead of you put it in the main function, so you put it flash, and then the next 10 rung you put flash again, and then the next 20 rungs you put flashing light again. So instead of doing so, you can actually put in a function and then just call the function afterwards, right? So this one is you can add the jump to subroutine. Okay, let's see the slide first. Okay, so this one is jump backward, what will happen? Okay, jump versus MCR. Okay, might come out in exam, who knows? Okay, and then subroutine. Okay, subroutine is a short program that is used by the main program to perform a specific function. All right, so this one is your main rung. So you have the input and you go to the jump to subroutine. When jump to subroutine is activated, the program will directly jump to the subroutine. We will search for the subroutine that this one denotes. Okay, so subroutine, and then we'll execute whatever in the subroutine, go to the return, and go to the jump again to the main functions, JSR, right? And then we'll execute whatever next. Okay. Simple, simple. So if you go to Logix Pro, if you go to the here at the very bottom of your function, let's how to unshow this taskbar setting. Wait, so okay. Oh, still still there. Okay, if you see at the bottom, you have the ladder 2, right? So this is the main function. Okay, you can see here. All right, and then you have the subroutine SBR 3, right? Subroutine 3, subroutine 4, okay, subroutine 5, 6, 7, 8, 9, right? Right. So this one, of course, depends on your PLC. So the bigger the PLC, will have the more subroutine options. So in this simulator, you have up to 9, 3 to 9. Okay. So you can put anything here, right, in your subroutine as your functions. Okay. So let's go to the ladder diagram again. Okay, so how to put your jump to subroutine? Simply, here. Okay, right, let's say here, right, jump to subroutine. Okay, jump to subroutine, right, U3. Okay, and then now because it is 3, it will go to the subroutine 3. Okay, so if it's 4, you can go to the 4. Okay, jump to subroutine, and then we'll go to the subroutine here, and then let's say you want to, to turn on your emergency light, for example. All right. Okay, like this. Okay, so whenever jump to subroutine is invoked, it will turn on the light. Okay, so you can have this multiple time as well, right? So for your control, jump to subroutine, maybe you want it here and anywhere. Okay, maybe after T on, right? Whenever you want to turn on that output. Okay, it's, as I said, it's very similar to the concept of functions in other languages, right? In MATLAB, for example. Okay, jump to subroutine. So let's say you want to put in your subroutine counter, for example, counter anything. Okay, you can put it here. Okay, so you have multiple options as well. Okay. All right. So I think this one is very simple. All right. Jump to subroutine. Go to the slide. Oop. Okay. Jump to subroutine. Unique file number. So this one is the unique file number. 3 denotes the subroutine 3 and so on. So for example, you can go up to 255, meaning that you can have 255 program files or functions in your main function. Okay, so return. Okay, so you can go to the examples in the slide by yourself. Okay, right, I think that's all for the PLC. So we have already covered all in the PLC, right? Yep. Okay, anyone have any questions for this? So MCR, jump label, jump to subroutine. All right, so we have covered today quite a bit on program flow. We call it program flow functions. Okay. Sorry. Right, anyone have any questions on jump to subroutine?
No questions.
Thank you.
No question?
Thank you.
Okay. If you don't have question, let me show you your assignment lah. Okay, your assignment. Where's your assignment? This one. Question. Sem 2. This one. Okay. Okay. Assignment 1. So how many assignment do you want in this semester? You tell me. 5 assignments, okay?
So 5 assignments?
Yep.
Too many, sir.
Too many. So how many? How many do you want?
Two.
2.
PLC 1, Geometric
Okay.
1.
PLC 1, pneumatic 1. Okay, let's see. Okay. So maybe the second one, we do for the preparation of your final exam, maybe. Okay. All right. So this one is project based. Okay. So the question, in a group of maximum 3, design a PLC ladder program in Logic Pro that includes these functionalities: counter, timer, flashing lights, logical comparisons. So this one up to you, whatever you want to use. Less than, right? So if you go to Logic Pro, logical, compare. Compare. So limit, more than or equal, not equal, less than, greater than, less than or equal, greater than or equal, right? So you can use that one. Okay. Either one, right? Either one of the logical comparison, MCR or jump label, and jump to subroutine. Okay. Make sure to use all available inputs and output available in your chosen simulator. You can choose either one from the following simulators in Logic Pro, right? So you can choose either door simulator, silo simulator, bottle line, elevator, and so on. So Pro, you can simulate instead of this IO, you can simulate, more realistically, right? So for example, the door, this one I've already shown to you, right? Silo, okay, silo example, right? So I think I've made silo as well. Where? Silo simulation, all right. Okay, so start, we go, the motor will go stop when proximity sensor detects stop, and then this one feels by, releasing the solenoid valve, and then when it is full, the level sensor will detect and the valve will stop, and then this one will move. Okay, and of course you also have the output of this run, fill, and full. Okay, stop. Okay, simulator or silo simulator, or you can have the traffic simulator, right? Traffic simulator, you have the output of the traffic lights, and also you have the this one, if you have the pedestrians, for example, or you detect the car, right? You know this? Like I said before, after my graduation of degree, bachelor degree, I work with the traffic light contractor. So this is one of the things that I did, embed the wet in motion sensor on the road, right, to detect the vehicle, right? When it is detected, maybe you start a timer, right? Up to you. So you can design your own traffic light, okay? Or you can choose, so bottom line, for example, right? Bottom line. So this one, you have the many inputs, right? So you have the, I think this one is the proximity sensor as well. You have these switches, okay, and also the motors, right? Lots of motors, right? Or you can choose also the elevator, all right? So when this one will stop, you press the button, this one will start going up, going down, all right? So you need to design this one, okay? So you can choose, of course, if you want to choose other simulators as well, up to you, right? BCD-IO simulator, all right? This one, maybe you want to use the math as well, okay? Dual compressor, right? So, you use the logical comparison to, for example, if the pressure is more than 10 bar, you need to stop the motor, for example, okay? Any simulators you can choose, right, for the assignment, but you need to make sure that you use all these functionalities. Okay, counter, timer, flashing lights, logical comparisons, MCR, or jump, or you want to use both can as well, and then jump to subroutine. Okay, and then the deliverables are 3. All right, so the first one is report, soft copy in PDF. All right, make some introduction, for example, the the problem statement is the traffic light, right? So you want to design a traffic light that is more efficient, right? For example, you say that the problem of this traffic light is that this one is silo. Traffic light. So the problem is this traffic light is that there's always traffic jam in this traffic light because of this one, have more vehicles in this direction, and normal traffic light use the timer base, right? So instead of using timer base, you want to use the sensor, for example. All right, so up to you. Or maybe you want to use the counter here to count the vehicles. Okay, you can do that. So state the problem statement, background of your problem, and then some introductions, and then the proposed solution. Okay, and then of course the logic program. So this one you do in the Logic Pro, and then you just cut and paste to your report. And then important thing is to discuss the flow, right? So maybe you have this, and then you just comment at the right side what happened here, okay? Or maybe you want to do it in terms of text, all right? Which is very difficult for me to understand. So maybe you want to use the infographics, flowcharts, or any other creative way of presentation, right? Okay, so report in soft copy and executable files. Okay, so like here what I did for the simulator. So flashlight like this. So you need to include these executables. Okay, and then also the presentation video. Okay, so you make a video to present your ladder program. All right, and then this one I put it 5 minutes. If it is less than 5 minutes, better, right? So maybe it's a very nice infographic video. So maybe 2 minutes or 1 minute, right? So you can upload to YouTube and paste the link in your report, or you can share the video in the zip folder, right? So all of this you need to zip and then submit to iTaklim, inshallah. Okay. So submission date here is 15. Okay, 15. Okay, any question on that one? 10 is good. Oh, you want to do 10 assignments, huh? All right, 10 assignment, 2 or 3, 2 is quite enough. What is silo? Silo is the, what is silo? I'm not sure, silo. But you can see the simulator here.
The food containers, we call it silo.
Oh, food container.
Anything
Oh.
that contain food, we call it silo. I think
I
so.
see. Okay, nice. All right, thank you. So silo is maybe this box, huh? You call it silo. Okay. Right, thank you. So any other questions before we postpone our class? So already 9:58, 2 more minutes. So maybe 1 or 2 questions more or suggestion. So don't forget we have class on Monday as well, and as well as quiz in the evening. Okay. Okay. So if you don't have any questions, so let's postpone our class today, inshallah. So thank you for you for joining the class. Oh yeah. Still have question.
No, for the quiz, what
Okay.
it will be in the quiz?
Oh, okay. So the quiz will cover on up to I think counter. Okay, counter. Easy one, easy one. So, okay, that's all. Okay, so thank you guys for joining the class. And if you have any problem, you can always, personally message me on WhatsApp. Okay. All right. So see you in next class, inshallah. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.